look at license plates as I either pass them on the street or in traffic, and to bring me some and see if we can solve them. So, can you name off one that you're going along first, please? You don't have to bring it up, just name whichever one you like. We'll try to solve it. 384. 384. Okay. 384. So the first thing that we're going to look at is do any of these numbers correspond to 11 up on the top? And yes, 8 and 3 do. So we can do 3 plus 8 equals 11. And if we're at 11, any number that we multiply it by is going to be a multiple of 11. So if we multiply that by 4, I heard you, 44. And that corresponds with a solution. So we get the star. Can we see any other ways? Let's do some running of the numbers. 38 plus or minus 4. 38 plus 4 is 40. That doesn't work. 38 minus 4. That's 40. It's 42, I'm sorry. And 38 minus 4 is 34, which is one more than we need over here, so that doesn't work. How about 84? 84 plus 3 is 87. That falls one short of 88, which is the number that we would need. So that doesn't work. And then 84 minus 3 equals 81. That doesn't work either. So we could go 3 times 4 equals 12, plus 8 would be 20, and 20 doesn't make it up to 22, so that's no good. I think we've run just about through them all. Let's see. Okay, I'm doing some exponents. 4 to the third power is 4 times 4 would be squared, would be 16. And then 4 times 16 is 64. So that's 4 to the third power, 64, plus or minus 8, or times 8. If we divide it by 8, that's of course 8 again, so that's still not going to get us to where we need to go. And 64 plus 8, or minus 8, is not going to get us to where we need to go either. So I don't see anything else in that vicinity. Now let's take a look at factorials. Factorials are the number multiplied by every number that comes before it going down to 2. So 3 factorial will be 3 times 2, and can't go any further, so m equals 6. And we express 6 with an exclamation mark. I'm sorry, 3 of the exclamation mark. That's 3 factorial. Now let's plug that in. 6, 8, and 4. Okay, there's one. How about 6 times 8? How much is 6 times 8?
48.
48. And you're left over with a 4. What do you do with the 4? Subtract it. And 48 minus 4? 44. Running out of room. So that is the second possibility using factorial, which is a little bit higher math than most of us in grade school are prepared for at this time. But there are so many answers to so many numbers. Have one more? Just call it out. 594. 594. Okay. 594. this match with anything up there? No, it'd be actually 9 and 2 would be 11, or 6 and 5 is 11, and we can't quite get there. If this was a 10, we subtract 4, and then give us 6 and 5, that would give us a solution. So we're going to have to get a little bit more crafty. And this is actually a good number because it deals with reciprocals. Okay. 5 times 4 equals what? 20. Okay. And we're still left with the 9. What do we do with the 9? Subtract, thank you. 20 minus 9 equals? And that corresponds with that, so that's a good number. Let's take a look at using the numbers and looking for reciprocals. Whenever you find two numbers that when combined give you the opportunity to reach a goal, such as 5 and 9 can combine into 59. 59 plus 4 equals 63. Yeah. 59 plus 4 equals 63. And that doesn't work. How about just 59 minus 4?
That could work.
55. Is that a winner? Bam, yes. So, when you get an answer like that, look for the reciprocal. And the reciprocal is taking the next two numbers, combining them, 94 plus or minus 5. How much is 94 minus 5? I'll give it to you, 89. That doesn't work. How much is 94 plus 5? 99. And that corresponds with 99 over there. So we have a winner. And this happens most often if you can find one solution where you combine the first two numbers and subtract or add the third number. Subtract or add the third number and end up with 11 or a multiple. If you look at the second two numbers, the same thing will happen. You'll be able to arrive at a solution. Okay. Let me just take a couple of quick looks down. 9 times 5 is 45. That's not going to do it. There's a possibility. Does anyone know what 4 factorial is? It's 4 times 3 times 2. And I'll let you figure that out. How much is 4 times 3?
12.
And how much is 12 times 2?
24.
Equals 24. So, we can use 4 factorial. That equals 24. Plus 9 equals what? 24 plus 9. 33. Absolutely perfect. And since 33 is a multiple of 11, that means that we can multiply the 5 times 33. And even if we can't do it in our heads, which I can't, we end up with another multiple, and we can say it is given So we don't have to go through the math. We know that it will add up to, or multiply up to a multiple of 11. All right. Now your brother brought a couple of license plates, and we'll take 2 from you and we'll be done. Give me a couple of numbers, please.
1, 2, 0.
I can't hear you.
1, 2, 0.
1, 2, 0. Oh, that should be easy. 1, 2, 0. And this one's going to be an interesting puzzle. Okay, I see you raising your hands.
With the 0 into 10, 10 plus 2 minus 1.
10 plus 2 minus 1. 10 plus 2 is 12. Minus 1 equals 11. Perfect. Very, very good. All right. Anyone else see a possible? How about combining the 1 and the 2 in 12?
Plus 10.
12 plus a 0 used is 10
Equals 22.
equals 22. Very good. That's also a winner. How about using the 2 as an exponent to square the 10? 10, and using the 2 as an exponent to square the 10, what is 10 times 10?
100.
That's it, 100. And what do you do with the 1? Subtract, that's right. So 100 minus 1 equals 99. That's a winner. Right there. Okay, give me one more, which will be the last one we'll do today. I couldn't hear. 3, 5, 6? Well, let's table that because 6 and 5 are already used. We've gone over that. 6 and 5 is 11, and then the 3 is 33. Let's try 7, 2, 4. Yes. Are you just trying to acquaint us with your beautiful, melodious singing voice? Okay. We already can see that the 7 and the 4 would make 12 times 2. 7 plus 4 is 11 times 2. 22. So we can already make this into a 22. How about if we subtract the 2 from the 4? No, that won't work. And so we'd still be left with 2. Okay, let's look. No, I can't see any further solutions to this. Okay. Cut!
Yeah.
I gotta get it ending now. Okay, this is going to be our ending, our last number.
Yeah.
It's 275.